Okay, don't know if you can see this. I can hold this up. It says the switch is now closed and the circuit comes to a new steady state. When they do this, you gotta know what's happening. Like, don't assume that this thing stays the same. They're gonna change stuff. They're gonna change components out. It's gonna be all kinds of strangeness. Make sure you pay attention to these things. So, I have that there. Let's look. D says to calculate the steady state current through the battery. So, what that basically means, I've redrawn this. Got your caps in pink and your resistors in blue. I mean, green, whatever color this is. I got the wiring in the battery, which is 30 volts. Alright, so, anyway, you've got a whole new situation here. I will tell you, at this point, your loops and everything are going to get really crazy. Don't mess with that. If you see them, if you see more than 3 or 4 loops, just leave it. That's probably not how you solve it, and that's not in this case either. The first thing, before you start jumping in and trying to calculate stuff on the battery, you got to pretend like you're in the circuit and what happens. I'm going to use the theme park thing again. Okay, so you're going here, coming into the park, right? Park's been open for a while, so guess what? These two really popular rides, the awesome roller coasters, they're full. The lines have stopped. Who knows what's happening. So you kind of come in, you're going on the tour here, you're going through here, and you look, oh, I want to ride that cool roller coaster. Roller coaster? You can't. It's full. The line's closed. It's ridiculous. So you go on and you get to ride that kind of maybe lame water ride, that your little brother or sister likes. Okay, that's fine. You go through here. And then you have 2 choices. You can either go to this other awesome roller coaster, or you can kind of go down this way and see what there is. Well, that awesome roller coaster is closed too. So this whole section, that means that this whole section, yeah, that's pretty much not going to happen. Should have gotten here earlier. This whole section, same thing. So you, being the current, just come right down here. Now, look, it's one of those stupid roller coasters that don't even have a loop in it. But that's okay. So you ride this. There's no line. You go through here. You can come back here. And now you're back at the gate. So, basically, the capacitors filled up and cut off that whole section for current. So what I'm going to do is show you what this is. This is the classic trick. This is so evil. Watch what happens. I'm just going to erase these. Let's just simplify this. I'm just going to erase both of these capacitor sections because they're, not going to happen. They're cut off. Oh my gosh, look at how easy that problem is. You have a super duper simple, that's a really 2 resistors and a battery. That's pretty easy. So, and both of these resistors are in series. See, you go up, if you travel, you go straight through and go through this one. So that means if you have resistors in series, you just add them up. So I'll put resistors in series, so that would be 40 ohms, or I'll just put 40 plus 20. This might cut off from the video, ohms, so therefore your resistance is 60 ohms. Now, as you may know, hopefully, think about how we did the model. Current ran faster when the battery, the voltage cheered louder. And if I'd put more people in backpacks in front of them, I would have put more resistors in the circuit and that would have slowed them down. So we'll just take the voltage, 30 volts, and divide it by your resistance, 60 ohms, and therefore your current's going to be 1/2, 3 over 6. Current is going to be, I'm going to just do it as a decimal, 0.5. Hopefully you know current is measured in amps. I like to just write amps. Too many A's otherwise. And that is part D.